Good morning, everybody. Today, actually, I am going to start the very basic part of quantum mechanics, which are known as the quantum mechanical postulate. And I am strictly following the Zettili book, chapter number 3. Okay, and these postulates are very essential to understand in order to understand the quantum mechanical phenomenon. Okay, and in this is based on this quantum mechanical postulate, quantum theory was developed, and through which we can analyze the microscopic phenomenon effectively. Okay, what happened before 20th century, at the end, up to end of 19th century, scientists thought whole physical phenomenon can be explained with the help of classical theory. Classical theory means Newtonian classical mechanics, thermodynamics, Maxwell electrodynamics. But at the end of 19th century, various probing technique, due to development of various probing technique, and it is scientists seen that, and it is seen that the microscopic phenomena, behavior of atomic and subatomic particle cannot be explained by the classical theory. Then they start thinking of a new mechanics, which is later named as a quantum mechanics. As I have already told the background of quantum mechanics, how quantum mechanics theory developed. Okay, now I'm not going to give the background again. So postulate. What is a postulate? Postulates are a set of assumptions based on which quantum mechanical theory is developed. This is the basic platform of quantum mechanical formalism. Okay, and this postulate means set of assumption, is totally based on experimental evidence, experimental observation of microscopic phenomena, but there is no theoretical background. Means validation of this quantum mechanical postulate you cannot be done using the analytical technique. Analytical technique means theoretically you cannot verify whether these postulates are correct or wrong. But it is seen that after formulation of quantum mechanical theory based on this postulate, it is seen that the theory is not effectively explain the microscopic phenomenon, but also it gives finer detail of microscopic behavior of the particle, and that is why these postulates are considered as a correct. This is the inferential consequence of the postulate. So what are the postulates? Why it is so necessary? First of all, classical physics mechanics, Newtonian mechanics, and quantum mechanics. So what is the difference between classical and quantum mechanics? You have to understand. So in classical mechanics, when you know, in classical mechanics, if we know the position and momentum of a particle, all other relevant parameters, for example, energy, E square by twice m, angular momentum, r cross p, momentum, these all physical parameters you can calculate using x and p. For example, velocity you can calculate v equal to x dot, acceleration you can calculate a equal x double dot. Similarly, what does it mean? In classical mechanics, if we know the position and momentum, then we can calculate the physical parameter. For example, energy, momentum, all of the relevant parameter we can calculate. Okay. Suppose, and this is in static information. This information, energy, momentum, it will give the information about the particle. But dynamic behavior of the particle cannot be interpreted from this parameter value. And dynamic behavior of the particle we can understand from Hamiltonian equation. What is the Hamiltonian equation? Q dot and P dot. Q dot equal to dH by dP and dH by minus dq. This is the Hamiltonian. So what is the dynamic behavior means? Suppose if you know the position and momentum of a particle and as well as other relevant parameter of the particle at a particular time, and what happened about the dynamic motion of the particle after time t, this can be answered, this can be obtained from the Hamiltonian equation. But what happened in quantum mechanics? This quantum mechanical postulate, whatever I am going to discuss here, this quantum mechanical postulate enable us to explain this phenomena in microscopic domain. Okay. Number one, it will enable to quantum mechanical state of any system using wave function. First, this postulate in quantum mechanics, this is a classical counterpart, this is a quantum mechanical counterpart. In classical physics, this I have told you. In quantum mechanics, how we represent? Classically, it is represented by x and p, but quantum mechanically, this representation is enabled by quantum mechanical postulate. First representation is a quantum mechanical statement. The state of a system by mathematical function. How to represent? What are the function acceptable function used in quantum mechanics to represent a particular state? This is the first point. Second point, how to extract physical parameter. Now, suppose in point 1 we have represented a particular state, quantum mechanical state, by suppose by mathematical function, which is later named as a wave function. Okay, and from the wave function, how can we extract the information about the system? How can we extract the energy, momentum, and eigenvalue, Hamiltonian? How can we extract? This is also enable us to with the help of quantum mechanical postulate. Third query. Suppose if we know the position wave function and physical parameter, we also know about the particular system in quantum mechanics. Then how can we represent the behavior of a dynamic behavior of the system? This is known as the time evaluation of the system. These 3 points is explained by the quantum mechanical postulate. First postulate in quantum mechanics, it will give wave functional representation, mathematical function, which is known as the wave function, to represent a particular state. In this system, how can we extract the physical parameter associated with particular quantum mechanical system? Okay, third point, time evaluation or dynamic behavior of the system. These all 3 points explained by the postulate of quantum mechanics. Okay. I am not going to write detail, but I will try to make you understand so that you can easily understand the quantum mechanical postulate. These postulates are very, very important, but this postulate will not ask in a net gate exam. Okay, but in order to understand the question as well as in order to solve the numerical problem associated with quantum mechanics, first of all you must have an idea about the quantum mechanical postulate. Then you can easily understand the quantum mechanics. Otherwise, without having the concept on a particular topic, if you go directly numerical, you cannot solve the numerical problem, because it is the net gate exam. All question are conceptual based. It is not long question. Okay, this is a short concept level question. Okay, first postulate 1. Postulate 1, state of a system. State of a system. Okay, first postulate tell that to every physical system, any physical system, suppose this is physical system, is represented by wave function. This wave function is represented in this Dirac notation. It is said that any physical system is represented by mathematical function which is known as basis vector in Hilbert space. This is Hilbert representation, or if you confuse, you can simply write wave function. Okay, or what do you understand? Any quantum mechanical system is represented by a wave function in Hilbert space. What is Hilbert space? Hilbert space is a n-dimensional linear space. Okay. Okay. This is the first postulate, and the wave function should be such that we can extract all necessary information about the system from this wave function. This wave function is, we have to represent in such a way that so that we can extract all necessary information about the system. For example, momentum, energy, eigenvalue, Hamiltonian, all necessary information about to know about the system can be extracted from the wave function. the wave function must have that type of behavior. Okay, this is called state of the system. Postulate 2. Postulate 2. Observable and operator. So first of all, what are the observable or dynamical variable? In quantum mechanics or in physics, what are the dynamical variable? Any physical variable that we can measure in the laboratory is known as an observable or dynamical variable. Okay, physical quantity. So here this statement means in quantum mechanics, all physical variable, for example momentum, for example energy, Hamiltonian, whatever it is, potential, whatever it is represented by operator. Okay. To every physical observable, suppose momentum is represented by momentum operator, which is equal to minus I is equals to del x. Energy is represented by energy operator, del T. Similarly, all physical quantity is represented by an operator. That means the statement is like that. To every physically measurable quantity or dynamical variable, there correspond to a linear Hermitian operator. Okay, this is the statement 2, observable and operator. This is the postulate 2. Postulate 3. Postulate 3. Measurement of operator and eigenvalue equation. Okay, so first postulate tell the representation of particular system, representation of particular quantum mechanical system, how we represent by wave function. Second postulate tell that every physical or dynamical variable is represented by operator in quantum mechanics. Okay, we understand. Third postulate tell that how can we measure the operator. This third postulate tell that is important. The measurement of operator is best understand with the help of mathematical function. So measurement of an operator is represent, suppose A is the operator. If we operate on a particular function, it will move to another function. This is, what does it mean? Measurement of an operator A can easily understand by eigenvalue equation. This is where A is operate on a particular state, it will move to the another state, and which new state is characterized by eigenvalue. This eigenvalue is the one of the measurement value of a operator A. Or you can say, if you don't understand, you see, suppose this is a particular body A. If I give a force, this state is represented by wave function psi A. If we suppose a ball, you consider football. So if we give a force, then it will move to the new state. New state is suppose psi A prime dash. Okay. Then how can you represent this state? We can represent force is the operator. We can represent like this: A equal to An psi A. What is psi A? An is the eigenvalue that will characterize the new state. Okay, how can you characterize the new state? So we will put some constant that value will identify, will characterize the new state. This can be understood with the help of this equation. Okay, this is the measurement eigenvalue. Sorry, fourth postulate, very easy. I am not going to give the detail. I will discuss again during the evaluation of numerical problem. Fourth postulate is that probability measurement. Now, why probability measurement is very essential in quantum mechanics? You see, in quantum mechanics, we are going to study the behavior of subatomic and atomic particles. Okay, we don't know the exact location of the particle. Suppose myself, Anil Hazarika, I can stay Guwahati, I can stay Tezpur, I can stay Jorhat, but you don't know my exact location. Okay, in that case, random motion of myself from Guwahati to Tezpur, Tezpur to Guwahati. So you have to represent me in terms of a three-wave function: Jorhat, Guwahati, Tezpur. Okay. In that case, you have to find out the probability of finding me in, suppose in particular state Jorhat, you have to find out probability of me, Anil Hazarika, in finding in Tezpur or Guwahati. This way you have to find out the probability. That is why probability measurement is very essential. Or you can say, suppose you consider particle in 1D box. There is a various energy level. Okay, you cannot say the exact location of the particle. It may be in the ground state, it may be excited state, according to the suitable condition. Somewhere inside the box. Okay, then we have to find out the probability whether this particle is located in particular region or not. So that is why we need a probability. Okay, probability formula is there. Pn An is written psi star psi, okay, psi n psi, this one. And you, I know you don't understand this equation, but I will give an explanation why it look like this. This is the probability of finding this system, finding the state wave function phi in particular state phi. This is the meaning. Okay, and I will give you explanation. Then you will understand otherwise. Suppose this is a wave function A1 phi 1, A2 phi 2 dot 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 An phi. Okay. Suppose particle in a 1D box, one-dimensional box. This is a suppose ground state. This is first excited state. This is end state. Or you can consider myself. This is suppose Jorhat. This is suppose Tezpur. This is Guwahati. Okay. So this is me. In quantum mechanics, always represent. Anil Hazarika is not represented as a nomenclature. Okay. You must use some wave function. Suppose this is Anil Hazarika. Okay. Then this is suppose A1 phi 1. This is Jorhat, and this Jorhat state is characterized by the constant. Okay. This similarly Guwahati. Suppose psi 2 is Guwahati. Then is Guwahati state is characterized by A2 constant. Now this means that this wave function means particular system can stay in phi 1 state, can stay phi 2 state, and can stay phi 1 state. We don't know. That is why we write the summation. Then suppose I represent in terms of a cat. This is cat vector. Cat vector is wave function, may be real, maybe imaginary, we don't know. That is why we just simply use. You can use like this, you can use like this. A1 phi 1. Okay. Do not confuse. A2 phi 2. This is nothing, just Dirac notation. An phi n. This is better you write this, then you will not confuse. Okay. Phi. Similarly, if I calculate the phi 2, it's just reverse. Now it is kept, it will become bra. A1 phi 1 plus A2 phi 2 dot 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 An phi. Okay. Now what happened? I'm erasing this line. Now what happened? Phi, this is phi, okay, equal to, it is simple product. You know that suppose A is a vector, twice I plus 3j. Okay, B is also vector, 3i plus 4j. Then suppose A dot B, okay, vector product. This is a vector in Hilbert space. It is a dot B will what? We always 2 into 3. We are not going to multiply 2 into 4 because I dot j will 0. So here is similarly also we can do. We will do the same thing. This is suppose A1 phi 1 phi 1. Okay. Only corresponding term we are going to multiply, because why we know this condition, na? Delta Mn equal to psi psi n equal to delta mn. This is a orthogonal 1 if m not m equal to 1, 0 if not m not equal to n. Okay, this condition we know. This phi 1 into phi 2 it will be 0. So we are not going to. This is square. Phi 2 square. So you can multiply, you can check it, no problem. Phi 2 dot 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 a n square phi n. Okay, this is orthogonal condition. Then it will be 1, it will be 1, it will be 1. This is because delta mn equal to psi n psi n. Okay, equal to 1 when if 1 this equal to 1 if m equal to n. So here 1 1 1 1. So it will be 1, it will be 1, it will be 1. Rest of the term will be 0. That is why I am not going to write this term. Okay, it will give what? A1 square, A2 square, dot dot dot, AN square. Or simply I can put sum of AN square. And this is the total probability. Okay, total probability. Suppose this is the total, I simply write equal to, I simply write AN square. Okay, total probability. Now, suppose I am writing again in cat form. This is suppose this one, and A1 phi 1. I am writing again only to make you understand. AN phi n. Okay. Now, if I suppose I want to measure. Suppose the meaning of this equation means this wave function can stay this state, can stay this state, can stay this state, and this new state are characterized by the corresponding constant term. Suppose I want to find the wave function. Wave function. What is the probability of this whole system in this state 2? What I have to do? If I multiply this function, suppose I need this part, then what I will do? I will multiply psi 2 phi. Then what happen? You see A1 phi 2 phi 1. Okay, this will be A2 phi 2 dot 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 AN phi 2 phi. Okay, this term will be 0 according to orthogonal condition. 2 is 1, not equal m equal to n. It is 0, it is 0, only this term is 0. So this will give you only A2. This means that, okay, this measure the probability of finding in order to find the probability of finding this system in state 5. Similarly, if I measure the phi n probability in order to find the probability, okay, then I will multiply this function with phi n. All other terms will be 0. Then I will get phi n. So finally, what we understand is that we understand this is probability AN in a state is what? This is give total probability. Okay, it will equal to square of the coefficient, and if you measure the particular state, this means that this is total probability numerical value is always 0 to 1, and if you want to measure the possibility of finding the wave function in state phi n, this is the meaning, and in state this is the function. This measure the possibility. This will modulus. Why modulus? Because probability must be positive. That is why modulus. It will give sum of AN square is square. Okay. This is what is the meaning. But in discrete, this is in discrete system. Suppose I am giving you one example. Suppose particularly that this question comes in the net exam. Suppose wave function of harmonic oscillator. Wave function of harmonic oscillator is written as phi naught plus t by root 2 phi 1. This is ground state. This is first example. Question is like that. If this is the wave function of harmonic oscillator and phi naught and phi 1 is ground state, then what is the probability of finding this particle? This is means harmonic oscillator. Finding the part. What is the probability of finding the particle in first excitation? How will you do? See, it's very easy. Once you must have understood. See, this is phi 1. You can represent bracket notation, no problem. This is simple notation. Just put this value. Okay, just put this value. Okay. Now I need to measure the probability of finding this system in state 2. Then I will multiply whole function by this one. Then what happens? This one phi. Then what happens? 1 by root 2 phi 1 phi naught 3 by root 2 phi 1 phi 1. Only thing that whenever which state you want to find out, you multiply with that state will be non-zero, all other term will be 0. This term is 0 according to orthogonal condition. So this part will be 0, this part equal to 1, so 3 by root 2. So what is the probability? Now this measure the probability of this system, this wave function staying in this state. Okay. Now what is the probability for this equation? Probability in state phi 1 equal to how much? Total probability. Total probability. This is phi 1 phi total probability. So how can you phi 1 measure? Just similar to previous one. Similar to previous one, you are getting how much? In denominator, you are 3. This is I am doing again. Phi equal to 1 by root 2 phi naught plus 3 by root 2 phi 1. Okay. Then this is phi 1 equal to 1 by root 2 phi naught 3 by root 2 phi 1. And this is a cat notation. It will be same, only reverse of that function. 1 by root 2 phi naught 3 by root 2 phi 1. Okay. But one thing is, remember, if suppose this term contain I is number, then you have to take minus I. Complex conjugation. Bra is complex conjugation of cat, or vice versa. Okay. And now you take the product. So this will what? Product of this term and this term, the corresponding term, this one and this one equal to how much? Product of 1 by 2, 1 by 2. This will become 1. Similarly, this will become according to vector, similar to vector product. It will give what? 1 by 2 plus 3 by, 9 by 4, or 9 by 2. 9 by 2 equal to 10 by 2. Okay? Or simply, now you have understood. Okay? This product, this probability means sum of coefficient means this is square and add up. Simple. No need to do this multiplication calculation. But simple, what I am giving a short tricks. This is in case of probability. What you have to do? See, according to this easy formula, this is easy formula. Only you have to remember this is a formula, original formula. Once you understand the original formula, then you have to find out. This is total probability. If I ask you what is the probability of finding this system in state 2, then according to this sum of coefficient. Sum of coefficient 1 by 2 plus 9 by 2. Okay, sum of coefficient. Okay, then this I need this state, to state coefficient, this one according to this formula 9 by 2. Okay, finish. This is the probability of finding the system in this question. This 3 mark question is very easy, and this measure the probability. Okay. Similarly, in this question, if somebody asks you what is the probability in 0 state? 0 state means this state. This is nothing, just square of coefficient 1 by root 2 square plus 3 by root 2 square and 1 by root 2 square. This is a probability according to this formula. Okay, this is how we have to measure. And remember, one thing is, remember in quantum mechanics, Every quantum mechanical system is represented as a superposition of number of multiple microstates. These are the microstates. These are the microstates. In statistical language, it is called microstate, and in quantum mechanical language, it is called basis vector. Basis vector means, suppose I am again telling you, suppose my location is 3. I can stay in Guwahati, I can stay in Tezpur, I can stay in Jorhat. How can you represent in quantum mechanics? So in quantum mechanics, you have to represent, suppose this is A, is suffix is for Anil Hazarika. Okay, then A1 5 Jorhat. Okay, A2 5 Guwahati. Okay, and A3 5 Tezpur. You have to represent like this. Suppose if I ask you, what is the probability of finding Anil Hazarika in Tezpur? How can you find out? Simple, nothing to do. Suppose this is a Tezpur, this is Tezpur, T Tezpur. According to this formula, sum of coefficient. Sum of coefficient means A1 square, A2 square plus AT square. Okay? Then divided by AT square. This is the probability of finding Anil Hazarika in Tezpur. Sometimes what happens? This wave function may be normalized. Normalized means square coefficient is, suppose A1 square plus A2 square, AT square equal to 1. Check the question. If the wave function is normalized, no need to write the denominator part. Just square the coefficient is the probability of finding particular state. Okay? This is the probability. Number 3, last postulate, postulate 5. This 5, there is only 5 postulate, okay? 5 postulate. Now, according to first postulate, we finally evaluate a particular mathematical function which is known as a basis vector or cap vector in Hilbert space, from where we will extract all necessary information about the system. Okay, number 1 postulate. Number 2 postulate, every physical variable or dynamical variable in quantum mechanics or physics is represented by operator. Number 3, now third postulate is that how to measure the probability, how to measure the particular operator. Operator means any dynamical variable. Arbitrary operator means it may be momentum, it may be energy, whatever it is. that will define by eigenvalue equation. Okay. Number 3 and number 4, how to measure the probability particular particle or system finding in particular state, particular microstate. It will given by probability theory, postulate 4. And remember, these 4 postulates will give information, static information about the system. But dynamic behavior of a particular quantum mechanical system cannot be explained by these 4 postulates. So last postulate will explain at particular time. Suppose you know this value. Value means you know everything about a particular quantum mechanical system. But after 1 hour, what happened about the system, or what it may move to another state. Suppose if you particle in a box. Okay, initially you represent this. Suppose I am giving you an example. This is a particle in a box. Particle initially fall in a ground state. This ground state wave function you represent I not equal to, suppose, rho 2 by a sine pi x by a. N is equal to 1 and cannot be 0 in particle in only box because n is principal quantum number. Then this is ground state. And from this ground state, what are you evaluate? You have evaluated the energy. Energy is equal to how much? N square pi square a square divided by twice m a square. So n equal to 1. So you find out the energy. Similarly, you find out the expectation value of momentum in ground state. So that means what? You come to know everything about the system. But if you give heat to the particle, after few minutes or few seconds, it will move to the another step. This is called dynamic behavior. So that dynamic behavior is known as the time evolution of the system. This will explain by postulate 5. Okay. Postulate 5. Postulate 5 is called time evolution of system. It is S operator. S is, remember, S is Hamiltonian operator. Okay, Hamiltonian operator. It may be Hermitian or non-Hermitian depending on potential. Normally Hermitian or Hamiltonian operator, usually Hermitian. Hermitian means eigenvalue of Hermitian operator is real. Okay, I will tell you after that. Just try to understand the postulate. E phi. This is a eigenvalue equation, and this is nothing Hamiltonian. Okay, Schrodinger equation. Okay, how it is Schrodinger equation? See, this is Hamiltonian. E means you can represent I is cos del phi by del t, or you can simply write H phi equal to E phi, or you can, this is operator simple, I is cos del phi by del t. You can simply write this equation. This is Schrodinger equation, time dependent Schrodinger equation. Okay, then last postulate says that if we solve the Schrodinger equation and if you find out the value of Schrodinger solution of Schrodinger equation, and it will give static information as well as dynamic information about a quantum mechanical system. These are the 5 postulates. Okay, what is the general solution of quantum? So I will not going to derive the Schrodinger equation. See, this is, I am writing again. I simplify the equation. Instead of writing bracket notation, I simplified version I have written. H is what? Total energy. So it will be what? P square by twice m plus V. Okay. Phi equal to I is cos del phi by del t. Okay. Easy. So I will replace in the next step. I will replace minus P equal to what? P equal to I is cos del Lx minus, okay, P equal to minus I is cos del Lx. Okay, if we put this value, you will get A square by twice m del square plus V phi. Phi is also there. My handwriting is not good, so I hope you will understand. Del square phi V phi equal to I is cos del phi. Now problem is that if you try to understand this equation, what happened? Left hand side does not depend on time. Right hand side it is depend on time. It is independent of x, y, z. It is independent of time. So, but both are equal. What do you mean? There must be some constant. This part must give a constant, and which is equal to the value obtained from this equation. This is the mathematical equation. Okay. Now, so in order to solve this equation, I am giving the solve, because if the potential is independent of time, okay, if the potential is independent of time, we can, this wave function contain R and T. Okay. R, or you can simplify x equal to, it will be better for you. So I will write, whatever it is, this wave function, whatever wave function, it is a function of R and T, space coordinate as well as time coordinate, because this is time part, this is space part, and this is separation of variable, suppose separation of variable T. Okay, I simply write phi and T. This is called separation mathematical formula. So how can you solve this type of equation? We have to apply separation of variable. Okay, separation of variable. This is a phi r. Phi is only depend on r, and T is depend on T. If we put this value, what you will get? C minus a cos square twice m del square. This is phi r, phi t. This is V phi t equal to, this will, because this function is depend on time, so phi I is cos phi dt by dt. Okay, you understood? Now this is independent of t, so t will come out. A cos square by twice m d square phi plus here t is come out v phi, because I have told you potential is independent of time, so it will be I is cos phi dt by t. If we divided both equation by h phi t, then what happen? This part will be t will come out. This will 1 by phi minus h square by twice m. Okay. Well square phi plus v phi. Okay, it will be equal to phi I is cos 1 by t dt by c. Left hand side is dependent on time, right hand side is independent of time. Okay. Now this equal to, I assume that this equal to constant, which is known as the energy. Okay. Now this part equal to E, this part also equal to E. Okay. See, now separate this value. 1 by phi minus d square, sorry, h cos square twice m L square phi plus v phi, okay, equal to E, and I h cos t del by del t dt equal to E. Okay, this is the first order equation. You can solve it. This is very simple equation. So I a t will come out. So I keep it. Now it is no question of partial derivative. It is depend only one variable. T equal to minus I h. Is it okay? Dt. So it will be log, and then it will be exponential. I am not going to give you next step. I will simply write t is equal to a e to the power I e t by h. We are getting this solution. This is a time part, and if we, this is a Schrodinger equation. This, if we simplify this equation, we will get this one: L square phi plus v h cos. Sorry. If we simplify this equation, twice m by h cos square e minus v phi equal to 0. This is a second order differential equation. This is time independent Schrodinger equation. This is a time dependent first order equation. Now, what is the general solution of Schrodinger equation? See, general solution, I assume this phi r t t. Okay. Now t is I got here. This solution you will obtain from solution of Schrodinger equation. This is a second order differential equation. Any differential equation, if you solve any differential equation, you will get a solution. If you plot this solution, then you will get a wave figure. Okay. This solution we don't know. We see, that is why we write phi n. Okay, phi n, and this part will add e to the power minus I e t by h, and E is the total energy of the system. Okay, this solution will give this solution will give complete behavior of the system. RT equal to an. This will always represent summation. Okay, in books you will find phi n e to the power minus I e n t by h cos. I replace e by en. En is a n state energy. So this is the energy. This is a solution of complete solution of Schrodinger equation. This solution will give complete information about the system. This part will give static information. This part will give dynamic information. In exam, what type of question comes? So suppose particle in a box. So this means that A1 phi 1 e to the power minus I1 t h cross plus A2 phi 2 e to the power minus I e 2 h cross with dot. Suppose this is a particle in 1D box. Okay, this is a ground state, and ground state is characterized by A1, and this is time dependent part. We tell the behavior at particular time where it will move, dynamic behavior. Similarly, this is the first excitation. So what do we mean by that? In quantum mechanics, if the suppose is in electron can stay ground state, excited state, first excited state, like that. So you cannot exactly locate the wave function. So you cannot say wave function of hydrogen atom or particle in a box A1 phi 1. We don't know. So that is why we will represent A1 phi 1 plus A2 phi 2 log to the n state. This is the mathematical representation of quantum mechanics. These are the postulates. Okay. This will give the complete behavior of the system. This will give the static behavior of the system. From this part, we will evaluate energy, total energy. For example, particularly in the box, we have evaluated from the wave function. Okay. We can find out, suppose in particularly in the box wave function, you are getting this is 2 a sine n pi x by a. This is a wave function. From this wave function, we are evaluating what? Energy. Energy is equal to what? N square pi square a square divided by twice m a square. We evaluate energy. We can evaluate momentum. So wave function will give the particular state, will give the information, relevant physical parameter, but dynamic behavior will give by the addition. In exam, what type of question comes? See, in exam, suppose particularly in 1D box, in exam, what type of question often comes? You see the question. Particularly in one-dimensional box is represented. One-dimensional box R0 is represented as A1. A1 is, suppose it is like that. A1, okay. 2 by A sine pi x a, n equal to 1. This is the first extent, or you can say like this also. Okay, you can do this wave function. You can write it like this. A2 2 by a sine pi 2 pi x by a. This is a wave function. Okay, this way you can express. Now, what is the value at time t? What is the wave function? Psi x for, how can you find out? It's simple. This is suppose a1. This constant I can consider as a1. Okay, capital A1. Constant is this constant, capital A1. This function will be 2 by a will come inside a sine pi x by a into e to the power minus that formula, because I have given you formula is like that. Complete solution, sum of an phi n e to the power minus I e n t by s. This is a wave function, wave equation in electrodynamics, because E equal to s cos omega. If you put s cos omega, then s cos cancel, e to the power minus I omega t. Okay, in electrodynamics you are getting this type of equation, right? E equal to E naught e to the power minus k dot x minus mod. Okay, that means what? E naught I kx e to the power minus I omega t. This I omega t is this part. Dynamic behavior. It will give the dynamic behavior. I will tell you. Then first part will be I E1 t by s cross. Similarly, A2 sine 2 pi x by a e to the power minus I E2 t by s cross. And after that, put this value E1 equal to pi square a square divided by twice m a square, and this one equal to 4 pi square a square divided by twice m a square. Put this value. This is the time dependent wave function. Okay, this way you have to find out. Or in one question comes in the gate exam. Okay, I am again telling you the harmonic oscillator wave function in previous example. This is the wave function of harmonic oscillator, and phi naught and phi 1 is the ground state and first section state. And this is represented is like that. This is represented is psi x 0. Okay, now we have to find out what is the time dependent wave function. How can you find out? Simple, it's not so hard. X t, because we know this general formula. You remember the general formula, sum of a n phi n e to the power minus I e n t by s. This is a1. Okay, and this is this part, and time part is missing. We have to put this value. This equal to 1 by root 2 will remain same, phi naught e to the power minus just I E naught P by square. This add this part according to this formula. Okay. Next part will be 3 by root 2 phi 1 e to the minus I into T by square. Okay. Now put this value. So what is E naught? What is E naught? We know this En equal to n plus half a square omega. This is one-dimensional harmonic oscillator. Okay, do not confuse. It is not three-dimensional harmonic oscillator. You one-dimensional harmonic oscillator, and n not equal, E not equal to 1, half a square omega put here, and E1 equal to how much? 3 by 2 a square omega put this value, and this is the answer. This is 3-mark question. Just don't confuse. It's a very easy question. Often comes in the exam, and they just want to ensure whether your basic concept is clear or not. Okay. In the next class, I will discuss what type of mathematical wave function is accepted in quantum mechanics. Practically, theoretically, mathematically, there is an infinite number of wave functions. But in quantum mechanics, we are only accepting particular type of wave function in order to describe the behavior of atomic and subatomic particles. Now, what are the conditions? How can we choose which is the best wave function that exactly explain the behavior of subatomic particles? There is a mathematical condition which is known well-behaved condition, and then I will go through the probability, Max-Born probabilistic interpretation, what is the dimension of wave function, how probability is become, what is the probability in three-dimensional, suppose hydrogen atom, what will happen in 2D case. So that things I will discuss in the next class. Thank you.